safety. Stay informed and follow advice given by your healthcare provider. A very warm welcome to our viewers and welcome back to the Form 5s. You are still tuned in to Eswatini TV and you are watching our program Home Study. I am Nogwazi Dlamini and with me right now in the studio is the Form 5's mathematics teacher, Mr. Zweli Mamba. Also joining us in the studio are our sign language interpreters, Zanele Fagutse and Linda Mamba. Zweli, how are you doing this afternoon?
I'm fine, Gwazi. How are you?
I'm great, thank you. So, what is today's topic about, and what are you hoping that your learner will have learned by the end of this lesson?
Okay, today's topic is an interesting topic on coordinate geometry.
Okay.
This topic is very applicable even in our everyday lives.
Okay.
You talk of the navigation systems in our cars. It uses coordinate geometry. So when you feed in the information in the navigation system, for example, if I want to go to Nespresso, so I will feed in Nespresso.
Okay.
So the navigation system will then show me where Nespresso is one. So that's coordinate geometry, locating Nespresso using coordinates. Then 2, it will be able to calculate the distance between Nespresso and where I'm at.
Okay.
So this concept is very important and applicable.
All right.
Yes.
Okay. So from 5s, if you remember what I said earlier, mathematics needs practice, practice, and more practice. So if you keep doing it, you will do well, I suppose. Just also to remind you, we are live on YouTube and on Facebook. And if you have any questions that you might have for your mathematics lesson, feel free to send us any questions that you might have on our WhatsApp line or on YouTube. Zweli, I will give it to you now to start your lesson.
Okay, thank you, Gwazi. Dear learners, it's a good day. Let's start our lesson. As I've already said, today's lesson is on coordinate geometry. This is the materials that you are going to need for our lesson. You need a pencil, a pen, a ruler, a squared paper, a mathematics exercise book, and a calculator. So make sure you have those materials with you in order to enjoy our lesson today. The objectives for this lesson, there are only 2 objectives for this lesson. The first one, learner, after this lesson you should be able to find the length of a line segment. Okay, so the length of a line segment given its end points. The second objective, you should be able to find the coordinates of the midpoint of a line segment, again given its end points. So those are the 2 objectives that we have to cover in today's lesson. Okay, so the prerequisite knowledge, the knowledge that you require for this lesson is you should have covered the XY plane, plotting of points, Pythagoras theorem, solving quadratic equations, and the mean. Okay, so please don't say you don't understand this topic. Okay, make sure that you have covered those topics I've mentioned as prerequisite knowledge for you to enjoy our lesson today. So I hope you are ready to start. Okay. Okay, so we have our introduction. Maybe we can just look at what coordinate geometry is about. Coordinate geometry is the study of shapes formed by coordinate points and their properties. So that's what coordinate geometry is all about. If you are interested, you want to know about what coordinate geometry is about, it's all about that. So I hope you are ready now to get into our first subtopic, that is the length of a line segment. Okay, so what is a line segment? A line segment is a line joining two coordinate points. So a line segment is a line joining two coordinate points. So what do I mean by that? I mean that if you have 2 points, so you have 2 points, the line joining those 2 points is what we call a line segment. Otherwise, a line can continue, you can draw a line and it continues to infinity if that's the case. So I hope we can continue now. So our first objective, as I've said, we should be able to find the length of a line segment. So let's start now. Look at these lines, these following lines. Okay, so here is our first line. Okay, so we are given this line segment. Notice it is joining 2 points. So we have those 2 dots, those are our 2 points. So that's a line segment joining those 2 points. What is the length of this line segment? What is the length of this line segment? You should be able to give the length of this line segment as what? As, I'm sure, dear Lena, you've got what? A 3. Okay. How can we find this 3? Or how did you find this 3? I'm sure most of you learners at home, you just simply calculated the number of squares you are having. 1, 2, 3. So you have 3 squares. 1, 2, 3 squares. So hence you say the length of this line is 3. Okay, but that way of finding a length of a line segment, I don't normally like it, okay, because there is something that you need to do before just counting the number of squares. The first thing you need to do is make sure you check what each square represents. Okay, how many units does each square represent? So you can come here, check from your x-axis from 0 to 1. To our first square we have a 1. So that means each square represents 1 unit. Hence you can go there. If you have 3 squares, so you know the length of the line is 3. Okay, there is another way, of course, of finding the length of this line segment. Okay, the other way of getting this 3 will be saying, you know, this line starts from 1 and it ends at what? At 4. And this line, notice that it is parallel to the x-axis, or we say it is horizontal. So we can easily get the length of this line by just saying 4, which is the end point, minus the starting point, which is 1. Then you get to this 3. So that is how easily you can get the length of this line. Okay, let's go to another line segment. Another line segment. Here is another line segment. Can you find the length of this line segment? I'm sure learners at home, you were able to find the length of this line segment. But I suspect some learners have given the length of this line segment as 2. You see, some are saying, what's happening now? Yes, the length of this line segment, dear learner, is not 2. Why are we saying it's not 2? Remember what we said. Before you count the number of squares, make sure you check what each square represents. Okay, so we can come to our y-axis because this line is parallel to the y-axis. So we can use this y-axis to actually find the length of this line. So let's check what each square represents. Check from 0 again to the first square. You check there, we have a what? A 2. So this means that each small square represents what? 2 units. Each square represents 2 units. So we can come here, we count it from here, we go 1, so we go 2, each square represents 2 units, we go to 4. So this means that, let me erase this. So now you agree with me that the length of this line segment is 4. But we can also use this other method that I said. Please make sure you use this method. You never go wrong. This is the starting point of the line. This is the end point. So we can simply say 6 minus 2. Then we get to that 4. I hope you are quite pleased, learners. Let's continue to another line segment. A third line segment, this one. Remember, we should be able to find the length of a line segment. So here is another line segment, quite different from the previous 2 lines. Can you find the length of this line segment, DLN? I'm sure now, students, you are struggling to find the length of this line segment. Why? This line segment now is no longer horizontal nor vertical. What do we do with such lines? This line is slanting. We say it's slanting, this line. How do we find the length of a slanting line? Okay, remember, learners, we have just seen that it's easier to find the length of a horizontal line. That is a line that is parallel to the x-axis. So we can say it's easier to find the length of a horizontal line. Okay, so notice this line. We can say this line, it has a horizontal distance, and it also has a what? A vertical distance. Those 2 lines, we can find their lengths. Okay, remember, we've already found the length of this line as what? S3, dear learners. How about this side, the other side? We say the length of that line is what? Is 4. Okay, so, and notice now, notice what we have now. We have a what? A right angled triangle. Okay, because we have a vertical line, and we have a what? A horizontal line. Okay, and they meet at this point. We say that the 2 lines are perpendicular, since they meet at a right angle. Okay, so hence we can now find this line, this slanting line, using the idea of what? What comes to your mind when you see a right angled triangle? What should come to your mind is what? Is a Pythagoras rule. Gwazi, it's like you have something to say.
No, can we take a bit of a break just to have a bit of water? Viewers, will be right back after this.
Okay.
Kumelula ukuthi ligciwane lecorona lisuke kulomunye lingene kulomunye uma sitawusonzelana. Singasita sinciphise kwanza kwalo ngekuthi sikhweshelane. Lokhu kusho ukuthi singachawulani, singathinzani njengokuhagana nje. Tikhweshise ngesigaba lesimitha kusuka kulabanye. Kumcoka kakhulu kuhlala uhlobile nekuthi hlobisa uma uke waphumela kubantu. Ngekubambisana sitakumisa kwanza kwaleli gciwane sibe ngulabaphilile. Eswatini sibambisene kulwa nekwanza kweligciwane lecorona.
Welcome back, viewers. You are still tuned into Eswatini TV, and this is Home Study, and we are doing from 5 mathematics with Mr. Zweli Mamba. Zweli, I'll let you continue with your lesson.
Okay, thank you, Gwazi. Welcome back, dear learners. Let's continue with our lesson. What I wanted us to note from our previous discussion is that it is easier to find the length of line segments that are either horizontal or vertical. We've seen that. But slanting lines need the idea of what? Of Pythagoras rule. So let me try and remind you what Pythagoras rule states. Remember, Pythagoras rule applies in what? In right-angled triangles. Okay, so if you have two sides, if two sides are known, you can find the what? The third side, if you know two sides in a right-angled triangle using this Pythagoras rule. Okay, so here is an example of a right-angled triangle. Okay, so we have this side, I'm marking with H. Side AB is called the hypotenuse side. Okay, it's called the hypotenuse side, and it is the longest side in a right angled triangle. Okay, so sometimes it's not easier to spot the hypotenuse side, but we can use the idea that the hypotenuse side is always opposite to this what? Right angle. So the hypotenuse side is the side opposite to the right angle. So Pythagoras theorem states that the hypotenuse side squared is equals to the sum of squares of the other two sides. So here is our Pythagoras rule, what it states. So the AB, which is the longest side squared, is equals to this AC squared plus BC what? Squared plus this BC squared. So we can use this idea of Pythagoras theorem to find the length of what? Of slanting line segments. So we can go back now to our slanting line. Okay, so now let's use the idea of Pythagoras theorem to find the length. So here is our slanting line. We had already found this side was 3, the other side was 4, so we can as well skip this. Okay, so here we are finding the length of the slanting line, that is the line AB, using Pythagoras rule. Okay, so notice here is our Pythagoras rule. We write it first. It's always advisable to write the formula first so that you don't forget it. So AP squared is equals to AC squared plus BC squared. Okay, notice we are not interested in AP squared. We want to find AB. Okay, so we have to remove this squared there. Okay, so how do you remove that squared? Okay, I'm teaching Form 5s, HCSE mathematics students, so it should be easy. Okay, so you just square root both sides. So AB will be equals to the square, you square root both sides. Okay, so the square cancel that 2, the square root cancel that 2, then we have AB is equals to what? The square root of AC squared plus BC, this comes here, plus BC squared. Hence now we can come with our AP. We already knew that AP is 3, so we have a 3 there. We'll have 3 squared, then we know BC is 4, so we have that 4 there. So we are just substituting to the Pythagoras rule to this equation. Okay, so then we work it out. You should be able to get to this 5. Okay, so the length of line segment AB is 5. Let's continue. Of course, we can deduce a formula that makes things easier for us. A formula makes things easier for us. Having that formula, we just plug in numbers, then we should be good to go. So here we are deducing the formula for finding the length of a line segment. So notice for the length of a line segment, I've used D. This D represents, it stands for the distance between two coordinate points. Remember, our objective was that we should be able to find the length of a line segment joined by two coordinate points. So let's deduce this formula. Okay, so we have our first coordinate. Because we are coming up with a formula, so we are generalizing. So we have marked our first coordinate as x1, y1, and our second coordinate b is what? Is x2. Let me remove this our b is x2 y2. Okay, so that AC now, this side AC, this side AC now will get it by saying the second x coordinate, which is x2, minus the first coordinate, which is x1. Okay, see, let me write it here. So you'd say x2 minus x1, you get that side. Okay, and also this side you just say y2, the second y coordinate, which is y2, you minus it with y1, you get bc. You substitute as we have done here. Where there is AC, we have that x2 minus x1. Where is BC, we have y2 minus y1. Okay, then we make AB the subject, so we get this. Then remember I said we normally use D, meaning the distance between the 2 points AB. We normally use D, or you can also write length of the line segment instead of writing that D. So this is the formula that we have come up with. Okay, so now we can use this formula, dear learners, to enjoy more questions where you are given the end points. So you just plug into that formula and it will give you the distance between those 2 points, or the line segment, the length of the line segment, I mean. So here is a question now. Find the length of a line segment joining these 2 points. So what we do, dear learners, is we have 2 points. So we have point A as 2,3 and we have B as 8,11. So we can let the first coordinate, which is A in our case, we let it be x1, the x coordinate to be x1, the y coordinate to be y1, because it's our first coordinate. That's it. Our second coordinate, we let this x coordinate to be x2, the other y coordinate to be y2. Check now. Remember our formula. We want the length of a line segment. We represent it as t, the distance between 2 points. Now what we can do, we just plug in. Where there is x2, you just go there, pick x2 is 8, you put it there. Hence we have this 8. Where there is x1, you come this side, x1 is 2, you put it there. Okay, y2, y1. Then after substituting to this formula, you are getting the distance between the 2 points as 10. Okay, yes, here is another question, dear learners. You can copy this question down so that you can try it at home. Copy this question down, you can try it at home. When we come back, we will further explain how to get the solution for this question. Okay, so the last thing is just the simplest thing, is the how do we find the midpoint of a line segment. That's the last thing, that's the simplest. So here is our example. We are given this line segment AB. We are asked to find the coordinate of the midpoint. Okay, what is the coordinate of the midpoint? So what is the midpoint? The midpoint is the point that is halfway the given line. So we have this given line AB. We want to find the coordinate of this midpoint. We have used the M to show that this point is the midpoint. What is the coordinate of this midpoint? I'm sure dear learners are saying that it's very easy. You can just use your XY plane to find the coordinate of M. What is the coordinate of M? Of course, learners, is what? Is 3, what? 4. Very easy, eh? Okay, so but it won't be always this simple. Remember, the objectives of the syllabus are saying you'll be given the end points to find the coordinate of the midpoint. So you'll be given something like this. Ask yourself, how can you find the coordinate of the midpoint, that M, that's the midpoint? You see, now we have the end point. So you see that we have to have a way of finding the coordinate of the midpoint. So we have to go back and let's try and check here. How can we get to this 3 and that 4. Okay, we have said m, the coordinate of m is 3, 4. It's clear from the graph. But ask yourself, how can we find this 3? Remember, we are using this x coordinate, the coordinate of the end points. So we have a, this is the x coordinate for a is 1 and the y coordinate is 2. For the other endpoint, we have 5, the x coordinate, the y coordinate is 6. So from these two numbers, how can we find this 3? Notice this 3 is in the middle of 1 and 5. So what we can do, we can simply say, notice that we can just take the average of 1 and 5, which is just the mean. We call it the mean. That's the correct way, because we have 3 averages. So the mean of 1 and 5, we just simply say 1 plus 5, then we divide by, we have how many numbers? We have 2 numbers that we are adding, so divided by 2. So this gives us a what? A 3. You also do the same thing this side. 2 plus 6 divided by 2, you get to the what? The 4. That's how you get to the coordinate of the midpoint. So I'm sure you'll be able to do the same thing here to find the coordinate of the midpoint. Remember, you take the coordinate of this point here and the coordinate of the point here. Those two, you add them. Then you divide by what? By 2. You find what? The x coordinate. You find the x coordinate. And you also do the same thing on the other side to find the y coordinate of the midpoint. So again, you will add the number that's here and also that's here. You add them, then you divide by 2. The reason I'm rushing now is that we are out of time, dear learners. It's unfortunate that this lesson was too long for the time that we have here, but I hope we'll have enough time to come and clarify things easily for you learners. But please do continue practicing, do more questions, then you should be good to go.
Thank you very much, Mr. Mamba, for that. And sorry, like you said, we have actually run out of time. We hope to see you again for the mathematics class. Thank you.
Okay, thank you, Gwazi.
Gwazi.
Yes, thank you, Gwazi.
Viewers, me and Lerato will be right back after this.